Today's video notes on 8-1 day 2. Today we're looking at similar polygons again, specifically how perimeter and area differ in similar polygons. If you remember, similar polygons are two polygons that have the same shape but different sizes, so their angles or corresponding angles will be congruent. However, their corresponding sides will be proportional. So let's take a look at perimeters and how perimeters will differ in similar polygons. If two polygons are similar by a scale factor of k, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. In other words, the ratio by which these polygons differ, the scale factor by which they differ, will be the same scale factor by which their perimeters differ. So here's KLMN is similar to PQRS, and if we add up all of the sides of the larger red polygon, quadrilateral, and divide it by the sum of all of the sides of the blue smaller one, then that similarity ratio will be the same ratio as a ratio of one of their corresponding sides, such as PQ over KL. And that all simplifies down to the scale factor K. Remember, scale factor and similarity ratio are used interchangeably here. All right, let's take a look at this first example. A town plans to build a new swimming pool. An Olympic-sized pool is rectangular with a length of 15 meters and a width of 25 meters. So let's just do a rectangular swimming pool. Here we go. This one's going to have a width of 25 meters and a length of 50. All right, so we'll just label those guys. There's our Olympic swimming pool. And then the new pool will be similar in shape, so rectangular in shape. All of the angles will be right angles, but it will have a length of 40 meters. All right, so now we're going to just shorten up a little bit here. We're not going to take time to make sure those guys are straight. There you go. It is 40 meters now instead of 50 meters. We want to find the perimeter, find the perimeters of an Olympic-sized pool and the new pool. Okay, so perimeter of a rectangle, we're just going to add all of them up around the edges here. So 50, 25, 50, 25, and that's going to give us a perimeter of 150 meters. Okay, but what about our perimeter of our new pool here? Well, we have to figure out what the corresponding side will be if they are similar. So what we're going to do is we're going to set up a ratio of our corresponding sides. 40 divided by 50 is equal to, and now our smaller one, which is what we're going to try to find, over the corresponding width of the larger one, which is 25. All right, so we're going to cross multiply here. We get 50x is equal to 40 times 25. And I'm just going to check my calculations here. That's 1,000. And then we're going to divide that 1,000 by 50. And x is going to come out to be 20. Okay, so our 20 here, if we add that up now, 40 and 20, 40 and 20, that's 60 and 60, that's a perimeter of 120 meters. Now, if we look at the ratio of our perimeters, putting the small one on top of the larger one, that 120 over 50, these all reduce down to 4/5. If you take 120 and divide that by your 150, you'll see that that is equal to 0.8, or which is the equivalent of 4/5. So the perimeter ratio will be exactly the same as the ratio of a pair of corresponding sides. All right, now that's for perimeter. And now remember, perimeter is a measurement of one dimension. Let's look at how area is a little bit different. Here it says the area of similar polygons. If two polygons are similar by scale factor k, then the ratio of their areas is equal to the square of the ratios of their corresponding side lengths. In other words, it will be k squared. Now, this should sound familiar. We did study this same topic earlier in the year. So let's take a look at these two similar polygons again. KLMN, that's the one on the left here in blue. PQRS, the bigger one here on the right. If we take the area of the larger one, PQRS, divided by the area of the smaller one, KLMN, it should be equal to the same ratio of the corresponding sides, PQ over KL. However, we're going to take that ratio and we're going to square it. So now it's going to be equal to that similarity ratio or scale factor squared. All right, let's look at our second example here that applies this same topic. In diagram, we got triangle ABC, the one here pointing to the right, is similar to triangle XYZ. We want to find the length of CD. All right, so here's CD. It's the height of this triangle, ABC, and it's going to correspond to, I'm just going to highlight that in blue here, it's going to correspond to ZW, right? So let's match up some corresponding sides here and see if we can't find out what that similarity ratio is. It looks like AC is 13, and it's going to correspond to ZX, which is 39. We're going to set that equal to this side length here, or sorry, this height of this triangle ABC. We're going to call that X. This is what we're trying to find here, which is CD. And divide that by ZW, its corresponding length, 36. All right, now 13 over 39, that reduces to 1/3. And so I'm going to use this pair here of ratios set equal to each other. This proportion, I'm going to solve this by cross multiplying. 1 times 36 is 36, and 3 times x is 3x. Now when we divide that by 3, we're going to find out that x is 12, and 12 is the length of CD, or the height of that triangle. Next up, it says if the perimeter of triangle XYZ, I'm just going to put this down here, perimeter is 108 centimeters, so all the way around, x to y, y to z, and back to x, 108 centimeters. We want to find the perimeter of triangle ABC. All right, well, remember, perimeter differs by this same scale factor, this same similarity ratio. So I'm going to use that same similarity ratio, 1/3, and set that equal to the ratio of their perimeters. Now the larger triangle here, XYZ, has a perimeter of 108, and that's going to go in the denominator, and we're going to let P be the perimeter of triangle ABC. So now we're going to take our proportion and solve that. That's 3P is equal to 1 times 108, which is 108, divide off the 3. And my perimeter now for triangle ABC, let's just make sure I get this right, 108 divided by 3, we can use our divide by 3 trick, is going to come out to be 36. All right, so the perimeter of triangle ABC is 36. We're going to append our units there. There we go, our perimeter, 36. Next, we want to find the area of triangle XY. I'm sorry, we are told that the area of triangle XYZ is 540 centimeters squared. We want to find the area of triangle ABC. Okay, so very similar to how we set up part B with perimeter, we're going to set up the same thing for area. But keep in mind that scale factor, which was 1/3, now needs to be squared, because our areas are going to differ by the corresponding side lengths squared, or our similarity ratio squared. So we're going to square that similarity ratio and set that equal to the ratio of our two areas. Now the larger one here, triangle XYZ, is going to go on the bottom again, 540. I'm not going to worry about the units just yet, and this is going to be, we'll call that variable A. All right, before I do my cross multiplication, I need to square this ratio. 1 squared is 1, and 3 squared is 9. So this is really 1/9. All right, now I'm just going to ignore this over here, and we're going to solve this proportion. 1 times 540, 540 is equal to 9 times A. We're going to divide off that 9. And 54 divided by 9 is 60. There you go. So 60, and our units here are centimeters squared. So the area of our smaller triangle ABC is going to be 60 centimeters squared. Alrighty guys, moving into example 3. Now we've got a polygon ABCD, so it must be a quadrilateral of some form. Is similar to quadrilateral HIJK. The perimeter of ABCD is 60 inches, and we know that side AB is 5 inches. Alright, so let's just sketch something here. It doesn't have to be perfect. Let's just say this is ABCD. We don't know that it's a rectangle, maybe it's a parallelogram. Its perimeter is 60, and AB is 5 inches. Okay, The perimeter of HIJK is 84, so we're looking at a similar figure, but it's a little bit bigger, so maybe it's like this, HIJK, very, very rough sketches. And our perimeter here is 84, and we want to find out what the length of side HI is. So HI is going to correspond to side AB, right? AB are the first two letters, HI are the first two letters. So we know that perimeters differ by that same ratio as our side lengths. So we can set up a proportion that looks like this, 60 over 84, here's my ratio of my perimeters, is equal to the ratio of, and then we're going to take AB's length, which is 5, over the missing side length HI. Let's just call this X. And now we have a proportion that we can cross multiply and solve. So 60 times X is going to give me 60X. 5 times 84. Let me quick check my math on that one here. 5 times 84. Yep, that's going to give us 420. And now that's really just 6 divided into 42. Right, we're going to divide off that, and that's going to give us an X value of 7. Now 7 represents the length of HI, which is going to be in inches, so we're going to make sure we got our units on there, 7 inches. All right, example 4, very similar to example 3. Again, we have a polygon ABCD, similar to HIJK. However, now they're going to give us the area. ABCD has an area of 4,928 square feet. BC has a measurement of 88 feet. HK has an area of 77 square feet. Find the length of IJ. So again, let's set up some pictures here. So here's A, B, C, and D. We know the area of ABCD is 4,928 square feet. We're not going to worry about the units. Segment BC is 88 feet. And again, it doesn't matter what shape we're looking at here. We just know the area. We know one side length. Now let's draw a little bit of a smaller, similar figure. Let's say it looks like this. Here is HIJK. All right, now we know the area of this guy is 77, and IJ is now the measurement that we want to find. So here's side IJ. It corresponds to side BC. This is our side length in question, and let's call that X. So again, we have two areas. We've got a missing side over here that corresponds to a side that we have. Let's set up a proportion. 4,928, the area of the larger figure divided by the area of the smaller one, should be proportional to the side lengths. Now, so we're going to take the larger side length, 88, and divide it by X. All right, now that we have our proportion set up, we're ready to start solving. However, one thing we got to keep in mind is that we're dealing with area here. And our areas of our similar figures are going to differ by our scale factor, or our similarity ratio squared. So we need to take that similarity ratio found by the corresponding side lengths and square it. Now when we square a fraction like this, we will square both the numerator and the denominator. And before we get going to that next line, we're actually going to simplify this 4,928 divided by 77. That all comes down to 64. So now we have the equation 64 is equal to 88 squared divided by x squared. All right, we're going to multiply that x squared out to both sides, and that's going to give us x squared times 64 is equal to 88 squared. X squared, here we go, 64x squared then is equal to 88 squared, and if we simplify that, 88 squared is simply 7,744. Next up, we're going to divide that by 64, and that's going to result in 121. So x squared equals 121. My final step is to take the square root of both sides, and x will equal 11. All right, so we found the value of that segment ij, and it is equal to 11. All right, in our final example for today, see if you can set up and find the perimeter of triangle ADE. That's the larger triangle here, A to D to E. Keeping in mind that triangle ABC is similar to ADE. and then solve the area for triangle ADE.